My name is Hector Jimenez, and for this project I designed a 3-function DC multimeter using the ATmega 1284 microcontroller. My complexities include a Nokia LCD display, 2 voltage divider circuits for measuring voltage and resistance, a current shunt monitor for measuring current, and I use the microcontroller's EEPROM memory to store values that are being measured. On startup, the device shows a menu that displays the available functions and the corresponding buttons to enable them. The first 3 buttons will enter a mode on the device, and the 4th will return the device back to this menu, allowing the user to select another function mode. The 5th button next to the ATmega saves data to the EEPROM. The voltmeter works using a voltage divider circuit, and the output of this circuit goes to an analog to digital converter channel on the microcontroller. The microcontroller uses this value from the ADC to compute the actual voltage. This configuration allows the user to measure between 0 and 25 volts, assuming the microcontroller is operating on a 5-volt power supply. To demonstrate this mode, I have a voltmeter for reference, an 8.4-volt battery, and connections to the 5-volt and 3.3-volt outputs of my power supply. If I press the button to save to EEPROM, the current value will be stored. A power cycle shows this value is in fact stored in non-volatile memory. This feature works in all 3 measuring modes. The ohm meter uses another voltage divider circuit. Connecting a resistor completes a voltage divider circuit and creates a voltage value that the microcontroller then takes in through a separate ADC channel and converts it into a resistance measurement. This mode also indicates continuity. For this demo, I have defined continuity to be a resistance less than 25 ohms. If I measure a 22 ohm resistor, the display will indicate continuity and a tone will sound through the speaker. If I measure another value, like this 4.7 kilo ohm resistor, the measurement will display but no continuity will be indicated. The ammeter works using an analog device's AD8210 current shunt monitor and a 1 ohm shunt resistor. The output from this device is used to calculate the current flowing through the resistor using the gain characteristics of the AD8210 that were obtained from its datasheet. I have set up an ammeter for reference and a potentiometer circuit to vary the current values for demonstration. As I adjust the current flowing through the circuit, the measured current is shown on the 2 devices for comparison. This concludes my demonstration. Thank you for watching.